Greetings and welcome, or welcome back as the case may be. Today I'm going to talk about another type of telescope that we use, and that is the infrared telescope. Now, as I discussed about optical telescopes last week, infrared telescopes come in two types. That's the refractor that uses a lens to focus the light down to a point, actually not a point, a plane, and reflectors, which are usually larger apertures and therefore can get finer detail, better resolution, because resolution scales as the diameter of your light collector, but also as the wavelength. So with longer wavelengths like infrared over optical, you typically get lower resolution for the same diameter of objective of light gathering instrument. So why, again, don't we use refractors? Well, with infrared, it becomes especially a big deal. We still use refracting infrared telescopes, but they're primarily for industrial and specific scientific purposes. And that's because a lens that allows, normal glass does not allow infrared light through it. So to get light through the lens, it has to be made with very special materials. It can't be just ordinary glass. So we run into the problem of we can't make them above a certain size, but also now we've got to have very special materials to allow the infrared light through, unlike normal glass. So mainly for astronomical purposes, we use reflecting infrared telescopes. And we also usually get them outside the atmosphere. There are a few ground-based ones, but they're tuned to specific wavelengths because there's a lot of things in the atmosphere that absorb or scatter infrared light, such as carbon dioxide, carbon monoxide, and water vapor. So these things make it where you've got to have very specific wavelengths coming through to your telescope in the infrared. So most are reflectors, and most are in orbit. And there's been a few. There's Spitzer, and nowadays there's the James Webb, which here's an artist's impression of what James Webb looks like. And you notice that it's got a huge mirror. It was so big that to fit it inside the rocket that launched it, it had to be in segments like that because it needed to be able to fold up. It also has this big heat shield that is always aimed at the sun. This makes it where it needs less coolant to keep the sensor cool, because that's another problem with infrared telescopes. You can detect infrared light. It just feels like heat on your skin. So infrared light heats things up. So you've got to cool your sensor back down. Otherwise, your sensor's temperature is what's detected by the detector, the CCD chip equivalent, which is a little different. It's coated with other materials than the usual ones for optical sensors. So other than that, it operates on the similar principle. Light comes in, hits the mirror, hits a secondary mirror, and is then focused through an opening in the primary, the big mirror, to the sensor. So again, refractors work much as, reflector infrared telescopes work much as optical. So why do we use infrared? There's one of the reasons. This is a difference between a Hubble image and a Spitzer image. So remember, I mentioned Spitzer was an infrared telescope we used back in the 90s and early 2000s. And you can see that it gives us a much different view. And that's because the gas and dust out in interstellar space over those large distances absorbs optical wavelengths. It does not absorb as readily infrared. And even if it does, it heats the material that absorbed it back up and makes it glow in infrared. So this is the view. It lets us peer deeper into these clouds. It allows us to see things like forming stars embedded inside the clouds. It allows us to see the extent of these clouds because they're glowing in infrared, not optical. They're not hot enough. So this is, again, why we like these things. And James Webb is giving us better, higher resolution images than this because if I remember correctly, Spitzer's mirror was about 0.8 meter in size. So about yay big. You can't see my hands because they're off the camera. And you can't see them because I've got the, so about yay big. It's probably not from the floor up to your waist in size. To the James Webb telescope's mirror, which is 8 meters, about the size of a tennis court. So James Webb will see in much finer detail, and if you go to NASA's website, you can see its images and see that detail, that peeling back of the gas that's in the way because the infrared penetrates it a lot better than the optical wavelengths. So that's infrared telescopes. And I hope you got something out of this video. If you have questions, by all means, put them in the comments. We'll get to them, or I'll get to them as soon as possible. If they're relevant to the subject at hand, I'm not going to answer about aliens in space. Sorry. So there we go. Anyway, I hope you liked it. If you did, give us that thumbs up. Give us a like. Maybe give us a subscribe. And we'll see you next time. Till then, hope you have a great day. Bye.